dear student, in last video I told you working of potentiometer sensitivity, and there I told you we can increase sensitivity by taking the longer wire, longer the wire AB, higher the sensitivity. So basically, practically how we construct potentiometer and what are the use. So first you need to compare the electromotive force of two cells. The potentiometer wire, in fact, a potentiometer wire is shown like this. It is a wooden board whose length more than 1 meter. The wire is spread over this, and here thick metal strips like copper, and then the length has become 2 meter, then 3 meter, okay, and then 4 meter. This is and A, this is B. So this is why AB has got increased length 4 meter, and by increasing this length we can increase sensitivity. I told you the longer the length, greater the sensitivity. So now driver circuit, which is used to develop potential difference. It is many ammeter here practically. It is voltmeter, the driver cell. It is low stage. Please listen very carefully and read the books, different books, not a single book. This is point terminal here. Please come to positive of ammeter, million. This is low stage here, and we connect this end here. So this circuit is driver circuit. When we close key K, a constant current flow through wire AB and produce potential difference. The use of this battery B is to drive the apparatus. This whole thing is potentiometer, but generally we treat potentiometer as long wire AB. Now this is used to drive. Now suppose we want to compare the EM of two cells. So what to do? Sorry. We connect कोई terminal of cells, two cells, जिनका EMF नापना होता है. Here is a two-way key. Here is a two-way key. है ना? This is two-way key. E1, E2. The two cells in lab used are one Lagrange cell, this one Lagrange, this is Daniel cell. Lagrange cell consists of a porous coat filled with carbon powder and carbon rod and Mn2 and zinc rod as a terminal. Similarly, this is Daniel cell, copper container which acts as polyterminal cell. Daniel EMF of Lagrange cell 1.5 and that of Daniel cell, you can read from practical book. It's in 1.1 volt, it's 1.5. But now we use different cells. Now this big point, they are connected to a high resistance galvanometer, box. Here we can take resistance of certain 1000 ohm, RB, and then we connect here galvanometer, and then jockey, J. This is a circuit diagram used to measure comparing of two cells. This is K1 key, two keys are there. how to check correctness. Don't get afraid when you go to lab. Observe the thing patiently. Two cells. Leg-lanchy cell. Leg-lanchy cell. Or this contain glass board or plastic board in which the porous core filled with carbon and carbon rod with having cap of brass will be potential and a zinc rod will be negative. This is Daniel cell. Now what we do, first of all we close this key K and note the current in milliampere here. This current here should not be less than 50 milliampere. It should not be less than 50 milliampere. Because potential difference will be there. Because of large resistance, this battery supplies more current. So here we should connect milliammeter. When I went to different labs, I found the connected ammeter ranging from 0 to 5 ampere. That because current of milliampere volt, the ammeter whose range is up to 5 ampere will not give deflection. Because 50 milliampere means how many ampere? 0.05 एम्पियर और वहाँ पर डिवीजन 1 एम्पियर का होता है। अगर यहाँ पर ये जो एमीटर है 1 2 3 भी है 1 2 3 और ये डिवीजन है 10 यहाँ पर, तो 1 डिवीजन 0.1 एम्पियर होगा और ये 0.0, तो दैट will not find diffraction. So use milliammeter in lab. Ask your teacher to carry you to the lab. That is must. So first of all we close key K and set current. Then close this key K1. Suppose take some high resistance out of certain 1000 ohm. Put jockey J at point A. You will get deflection one side. Then put jockey J at B. You will get the other side. I have told you that galvanometer has scale like this: 0, 10, 20, 30, 10, 20, 30, or 10, 20, 30. When no current flows through this deflection pointer points at 0. So when you place jockey at A, deflection to this side, at B, this side, it means your circuit is correct. There occur many errors or mistakes while connecting. First of all, the end point of connecting wire should be cleaned, by sandpaper. Then check whether POI terminal of all these cells and battery are connected to point A. Distinguish POI terminal of the cells and battery in the lab. Positive लिखा रहता है, but in case of cells, I told you here, in case of Lagrange, carbon load is positive, zinc load negative. Here copper container connected with some screw that act positive, zinc load negative. When you find deflection both sides, then it is correct. Now we find take the distance of the key K, we find a null point. Actually here will be a meter scale. Yes, sorry. Here will be a meter scale attached with this. And that is marked 1 to 100 and 0 to 100 this way. 0 to 100 here and 0 to 100 here. Suppose we get null point like K1 here at point J. When you get nearly null point, insert this plug of 1000 ohm here and then find null point. It may be little away. So suppose you get null point here. So how to measure length? This 1 meter. So how much is this? That will be read on this line. Suppose by 1 meter and it comes once 60 centimeters. So that length will be L, and then E1 equal to KL1. This length is L1. This whole length is L1. 100 plus 60. Suppose it comes. K is potential gradient remain constant for a given current. Now open this key K and close K2. Again take some resistance out. Find nearly one point. Suppose it comes at this point. Suppose we have to cell less than this. And again to find the exact value, take insert this key here and find one point. Suppose length it comes here at length L2. Then E2 will be KL2 or E1 upon E2 equal to L1 upon L2. So by finding the length L1 L2, we can find out the ratio of EMF. If one of the cell EMF is known to us, and generally in finding the EMF cell we use one single cell whose EMF known. Now suppose E1 is known, so E2 can be find out easily without measuring this current and this current is there only just to see whether current is passing or not and how much current. Now if you want to take more reading as we do in practicals, we take many observations. You can increase the current and find L1 and L2. With increase current here, please note, if you increase current, suppose first it was 50 milliampere, now you make it 100 milliampere. So length of L1 and L2 will be different but less than these L1 and L2. Suppose length L1 is 160 centimeter. So with the increase it may be less than 160, maybe 140, maybe 130, etc. Similarly L2. If we decrease current, then length will decrease. So this way you can measure electromotive force by potentiometer. Now there is another use, number 2 use है to estimate the variation of internal resistance of cell. We have only these 2 uses here, but what we use here, we can find out resistance also. The same diagram is there. Nabi, this diagram we use, but this is a potentiometer. This is driver cell. So it is meter scale here. Now the cell EMF napna, internal resistance, this point A. Connect position of cell and here connect another key K1, so it is K here. And a low resistance box. Heavy resistance equal to 10 ohm only. RP. And again high resistance box. Actually in place of this some people connect high resistance in series with parallel. So shunted cannon will work. And then RP. And then galvanometer and jockey, the same way. Actually resistance of cell, internal resistance of cell, I told you while defining internal resistance, is not a fixed value, keep on varying. If you keep on using the cell, internal resistance will increase. So we connect this circuit diagram used to find the internal resistance of cell. So first of all, the same way we check whether circuit is right or wrong. close key K and key K1 off. Take some resistance, put the jockey at point A, deflection one side, put jockey at B, deflection other side, then circuit is correct. If not correct, maybe current is more here. This current should not be less than 50 milliampere. So you have checked. Now first of all, what to do? Keeping close key K1 off. Now find the null point. Keeping K1 off. When K1 off, no current will flow this and at balance point. Keeping K1 off, open null point, at null point, no current. Let this length be L1. So then E is equal to KL1. Now close key K1 and using the same process, find null point. That length will L2 will become less. ये मान लो L2 आया अपने यहाँ. So then, because when the circuit is closed, some current will keep on flowing. So potential difference here will be less than EMF. So then V is equal to KL2. V is the terminal potential difference when whether there is null point or no. If this closed circuit is there and some resistance has been taken out, by taking a resistance here 1 ohm or 1.5 or 0.5 ohm, we find L2. So when current is drawn from cell EMF less than EMF, so potential difference less than EMF. Potential difference in this potential less than EMF, to L2 less. So E upon B is equal to L1 upon L2. But our aim here to find internal resistance. How to find that? You know, when this K1 is K on, some current I will be flowing here, then E is equal to IR plus IS है, IS plus IR, यानी कि E equal to I bracket S plus R as the resistance taking from this when K1 closed, and B equal to IR है IS. From these two we get E upon B as S plus R upon S. Now comparing 1 and 2, suppose this is equation 2. Comparing 1 and 2, what do you get? S plus R upon S equal to L1 upon L2, or R is equal to L1 upon L2 into S minus S, यानी कि R is equal to S common L1 upon L2 minus 2. By knowing L1, L2 and this resistance, you will find internal resistance. If you take S different, suppose initially take 1 ohm and then you take 1.5 ohm, 1.3 ohm, so all resistance reading will be different. But don't take average there, okay? Average internal resistance. You will write the answer, okay, resistance internal share vary from this ohm to this ohm, minimum to maximum. That's all. Now I will take some numerical regarding potentiometer.